remainder of the questions in your packet are conceptual questions that ask you to compare the velocity and acceleration horizontally and vertically for different objects moving in different ways. I'm going to do the first one for you, and then you will do the rest on your own. On Monday, you will have a quiz that is identical or almost identical to one of the questions in this packet. I highly recommend that you work hard Thursday and Friday trying to solve these questions on your own, and then you spend the weekend looking at my solutions to check your understanding. Feel free to email me anytime to get some help. I'm going to start by reading the question, and I think that's actually a place that a lot of people get tripped up, so I'm going to try to be very careful about it. Two identical rocks, that probably means that they have the same shape and mass, but I also remember that mass doesn't matter in motion of things that are in free fall. So that's not that important. They're thrown horizontally from a cliff. Since I see this word horizontally, that tells me that all my velocity is in the x direction, and my initial velocity in the y direction is 0 for both rocks. With rock A having a greater velocity at the instant it is released than rock B. So the instant it is released tells me I'm talking about initial velocity. So initial velocity in the x direction for rock A is greater than the initial velocity in the x direction for rock B. Use a coordinate system with down as the positive vertical direction. So that means down here is positive y, and away from the cliff as the positive horizontal position. So this is plus x. And with the origin of the coordinate system at the bottom of the cliff directly before the release point. So if I'm talking about the path that the rock takes, one is dropped and one is projected and lands. Sketch the velocity versus time graphs for each of the rocks. So it's super important that I keep reminding myself that we're talking about velocity, we're not talking about position or acceleration. So my velocity in the horizontal direction, 1 is going to be constant because these objects are falling. The only force acting on them is gravity, so the only acceleration is going to be downwards from gravity. So there's 0 acceleration, a constant velocity. That's what constant velocity looks like on a velocity versus time graph. It means my velocity isn't changing at every second. I have the same velocity. Rock B also has a constant velocity, 0 acceleration, because in the horizontal direction, because it is also in free fall. The only force is the force of gravity, and that's down. But, as I wrote up here, my initial velocity in the x direction for A is bigger than my initial velocity in the x direction for B. So I'm going to have a flat line, but it's going to be lower than this flat line was. In the vertical direction, I already said for both my initial velocity is 0. So I'm going to start at 0. I have an acceleration of 10 meters per second squared. And we said that down is positive y. So my acceleration is my slope of my velocity versus time graphs. And this is for the vertical velocity. And so I am going to have lines with a positive slope of 10 meters per second squared. When the question asks which rock hits the ground first, it's asking what is the time to go some displacement in the y direction. So one's dropped, one follows this trajectory. This is delta y. And because in the y direction, my initial velocity is 0, my acceleration is 10, and my delta y is this height. And this is the same for both rocks. They both hit the ground at the same time. Take a second to get these ideas down on paper, and then I will rewrite this reasoning in full sentences. Remember, you can always rewind to get back to this original summary of reasonings. So, I would say they both hit the ground at the same time. There is no vertical velocity initial velocity. In either situation, and they both have the same downward acceleration, that's gravity, and displacement, that's the height of the cliff. Which means time to travel that displacement in the y direction must be the same. The next question asks which rock lands farthest from the base of the cliff. So, I have one of my projectiles landing here. I have another landing here, and I want to figure out which one is closer, A or B. And so we already know that A has a bigger horizontal velocity as B. And we also know that they both spend the same amount of time in the air. So my answer is that rock A lands farther from the base of the cliff This is because in the equal amount of time it takes each rock to hit the ground, rock A has a higher constant velocity. So it has that velocity the entire time, which means it has a greater displacement in that time. And I'm reminded of this equation. It's one of the first ones I ever learned. It's that average velocity is displacement over time. And because we have a constant velocity, our average velocity is the same as our velocity at any point, because our velocity doesn't change. If we took the average of a bunch of numbers that were the same, we'd get the same number. So, if this is bigger, and this is the same, then this must also be bigger. So my answer is rock A. Good luck with the rest of your packet. Don't hesitate to ask me, your peers, Miss Wong, or anyone else who might help you questions.